Hi and welcome back. Now let's have a look at implementing web applications. They have the same considerations as implementing any other systems, except for the fairly slow communication between modules. Now they have been somewhat dismissively summarized as a programming language with a database and a HTTP front end. Now that's probably simplifying things beyond much usefulness, but I guess in some ways that's right. You have to have the HTTP handler at the front so that you can transmit across the internet, but that's not all you need. Of the architecture concerns that come up from time to time, actually all the time, the main concerns are about coupling and cohesion. Increasingly, we're finding that web systems need to have their components very well sorted out. They have to be highly cohesive and loosely coupled. A number of iterations of architectures for some pretty big commercial systems have pointed out time and time again that the complex interconnections that tend to arise in monolithic systems have to be sorted out when you're going to web-based systems or pretty much any other component-based systems. They just happen to be very important in web-based systems. A lot of the times in web-based systems you face a choice between having a thin client or a fat client. Now the client is the part of the system that is visible to the end user and that runs on the end user device. Now a fat client has a lot of the processing on the end user's system. So whether that's their desktop or their tablet or their smartphone, doesn't matter, but a lot of the processing happens there. Now this is most suitable when a lot of the information is available at the client side of things, and there's a minimal need for information from any form of central site. This might happen in something like a loan application where the client themselves are providing most of the information. In contrast to that, a thin client system or fat server system is one where most of the information is available at the server end of things. Now you can imagine this is where there's a central repository of information, such as you might have in booking concert theatre tickets. The state of all the concert theatre tickets resides in one place, and that will be at the center, not at each client side. Of the main architecture designs, Model View Controller seems to be a extremely popular one. It seems to work very well. Now Model View Controller is, if you like, you have your database which models the world. You have your controller that deals with all the coordination and transaction flow, workflow. And you have your view, which is that part that sits on the client side and provides the view of the model to the user. It's used for quite a number of systems. It's very popular in things like blogs and things that just generally display information. However, a recent variation has been the ADR, Action Domain Responder. Now, where this arises is when the application, if you take the application's view, it looks as if there are a large number of components out there that can generate an event to require some activity. It happens that just because all of these components sit on the client side and probably sit in one composite screen doesn't matter as far as the application is concerned. The application sees a lot of independent components that can provide action. Now the domain takes those events performs whatever activity it needs to do, and then provides the output to the responder, whose job it is to format that information into some sort of an HTTP response to go back to the client. So that's the action domain responder. Scalability is a fairly large concern in web systems, and this is because you may start off with a small number of users, but you could rapidly ramp up. This is because your number of potential users is well, it's about 3 billion, which is a great deal more than if when you have a company internal system. So the need to potentially to scale up is quite high. One very common architecture that makes this more possible, but doesn't incorporate scaling itself, is the in-tiered architecture, where you separate the application system in tiers, and then you can potentially, anyway, you can take one of those tiers and replicate that or scale that tier up in some way, independent of all the other tiers. There are two normal methods of scaling, and one is horizontal scaling. And this is where you take some component and you replicate that component so that you have multiple of them, and potentially any one of a number of these components could respond. Now that usually requires some form of load balancer in front of it to determine where any particular event is going to go. And it can require a certain amount of coordination if you're relying on a response to come back from a particular client in an ongoing transaction. So that's one complication that can come in there. In comparison to that, we have vertical scaling, and this is where instead of having more of them, you have a bigger of them, and there's obviously limits to that. However, some systems are very difficult to split out into scalable components. So here you have just this the one system, and you try and scale that by making it bigger, or making the system on which it runs bigger, faster. This suits very slow changing applications better than that suits faster changing applications. Now, when you're looking at implementing things on the internet, there are an enormous number of resources that are available to you. There are architectures, there are frameworks, there are components, there are component libraries, there are things like databases you can buy. There's a number of things, and don't try and reinvent it. A lot of these things have been built, tested, tried out, and they work pretty well. So it really pays to take advantage of the things you can readily buy and implement. And sometimes you don't even have to pay for them; they're just free. So don't reinvent the wheel. Just take advantage of what's available.